Strokes and spinal cord injuries were once thought to have little or no possibility for significant recovery. But a technique known as functional electrical stimulation, FES, is showing that the brain can learn new pathways to a patient's muscles. Joining us now for more on these developments, Dr. Milos Popovic. He is Associate Director of Research at the Toronto Rehabilitation Institute and Toronto Rehab Chair in Spinal Cord Injury Research. And we welcome you to TVO tonight. Can you give us a sense off the top, how many people suffer from the after effects of having had a stroke?
So in Europe and US and Canada combined, it's almost 1.9 million people.
1.9 million. And how much money do you think we spend tending to the needs of that 1.9 million people?
So in US, the estimate is about $35 billion.
35 billion.
Exactly. And in Canada, we're looking about a tenth of that, so 3.5 billion. Roughly.
You have created a graphic that maps the journey you took in creating this device that is on the table beside you. It's called Mind Move, M-Y-N-D.
Yes.
I presume that means because it's mine. Is that right?
No, actually,
no?
The name came, we spent quite some time trying to put the name together, and this Y is deliberately there to a little bit jerk the reader, so they expect it's mind and move, but this Y is wrong spelling, and it kind of focuses you to pay attention to what
Well, it worked, because that worked on me. Well, the Mind Move technology for stroke and spinal cord injury victims, it shows the process of getting underway in 1997, if you go to the top left-hand corner of that graphic. Can you just sort of walk us through, from that starting point through to what you have labeled the aha moment in 2001? Which you see there on the top, right?
Right. So essentially, when I started working in this field, with my team, we had to first develop the neuroprosthetics systems because they're not off-the-shelf devices. You cannot simply go and purchase them. So we spent a lot of time putting the technology together and trying to actually demonstrate that you can deliver artificial movements to the limbs and that they're repeatable, they're reliable, and that patients respond to them favorably. And one of the fundamental concepts at the time, we were talking 97, 98, was that the patients will not improve. So you will need a technology that will substitute the function that they have lost due to stroke or spinal cord injury. So our focus was to design a system that will nicely replicate different movements of the hand that the patient will depend every day. So the patient will have this neuroprosthesis on the body every day, and will fire the device will fire the muscles in a coordinated manner to provide that movement. And so that was the focus of the effort, and we were fortunate to build a system which was fairly reliable, and we could apply it to multiple patients to see how it actually works.
And what was the aha moment?
So the aha moment was, as we were delivering these systems to our patients to take home, with a clear anticipation that they will use it every day and as an assistive device, and they will come back for repairs and maintenance, whatever. We start getting patients coming back and saying, we don't need this device anymore. And if you work in assistive technology field, this is not an unusual event because people return devices because they don't like the color, they don't like the function. It's very difficult to use it because the nurse or family member doesn't want to put it. So we expected one of those things to happen to our device.
They don't normally return it because they don't need it anymore.
Exactly. So that was a surprise because patients start telling us essentially that we don't need it anymore. Look, I can do it without a device.
Earlier this year, the University of California at Irvine released a video of a paraplegic man using FES to walk. Let's roll some of that video, and we'll take a look at that right now. And this is really...
Start walking?
Well, look at this.
Great.
Tell us what we're watching right now insofar as the functional electrical stimulation device is doing something that apparently is allowing this person to walk.
So what is really exciting about this technology, the walking per se has been done and it's been available for many years. So you can fire different muscle groups, and in this particular case, you can fire peroneal nerve to generate flexor withdrawal reflex, meaning the system allows the lifting of the foot and generates walking-like sequence. But what they have done essentially is they have connected it to the brain-machine interface. So they have used the signals in the brain to trigger the movement of of the functional electrical stimulation. So that's what is different and unique about this particular.
And the harness, what's the story with that?
The harness is actually supporting the weight of the subject as he's walking through the room. So it's for safety, and sometimes it's used to offload the weight of the patient, because sometimes patients are not able to sustain the entire weight of the body.
Now, that's University of California, Irvine.
Yes.
You, on the other hand, are concentrating, I gather, on arm and hand mobility rather than walking. How come?
Actually, we have been working with the locomotion system. However, we believe very strongly that the priority for patients is an upper limb function. And the reason for that is when a person doesn't have an upper limb function available, so hand and arm, they essentially depend on others to perform activities of daily living. So when one interviews the patient, what is their priority? We walkies, we will think, it's a walking that's really relevant for the patient. But the patient will tell you, no, I really need an upper limb function, because then I can do things on my own, I can perform tasks independently, and by doing that, I get my dignity back and I get my independence. And by getting independence back and getting dignity back, automatically the number of people that need to attend to this person every day goes down substantially, which reduces the costs, makes people independent, and they can actually go back to work. Locomotion is not critical for going back to work. Hand function is, or going back to the community and being able to participate in your community.
Interesting. So you got that. You chose that approach because you listened to your clients.
Exactly.
Gotcha. We got another video to show. This time, one of your patients. This is Andrew Genge, suffered a stroke, serious rugby injury. Let's roll the clip and see what's up. Go ahead, please.
If somebody has a high-level stroke injury, probability of improvement is less than 10%.
His right arm and right hand were most slow in recovery.
If Andrew would join rehab 10, 15 years ago, expectation would be that most likely his arm and hand function would not improve.
I went from paralysis in my right arm to moving my finger, and I was completely amazed by it. It did wonders for me. It pretty much gave me back my arm. I would describe myself as having 90% movement in my hand and arm thanks to FPS.
That's unreal. He's in his 20s. He had a stroke in his 20s.
Yes, actually he was 17 or 18 or something around that.
And now look at him pumping iron.
Exactly.
What did you do?
So what we actually have done, we have trained him. So the way how the technology essentially works is you ask the patient to imagine different reaching or grasping tasks, and as the patient is struggling to perform the task, we artificially fire the muscles to actually generate that movement that patient is trying to do. And as the movement is generated, you provide all the sensory feedback to the central nervous system, and the desire to move and the imagery of the movement plus the sensory feedback help retrain the parts of the brain that were not damaged by the stroke to relearn how to do this task.
And how typical is his recovery compared to others?
So we had his recovery, as you see it from the beginning of the treatment to the end of treatment, is very typical. What was exciting for us, because we haven't seen him for 7-9 years, is that when they filmed him for this clip, he actually dramatically further improved and gained strength, and he was able to do chin-ups and push-ups, which I didn't think he would be doing.
Because he's showing off for the camera.
Exactly, probably.
Now, I hate to be a killjoy here, but what about the prospect of a relapse? Is that possible?
Actually, all the patients that have participated in our program and used the technology essentially either kept the function which they gained or they improved.
Do you have to do what you do immediately after the injury takes place, or is it better to wait some time? How does it work?
We believe it's beneficial to do it early after the injury. Not immediately, but leave it a couple of weeks until the patient stabilizes. And then, because based on the literature and our experience, this is the time that the patient is most prone to recover and to accomplish some significant gains. We have had chronic patients who are 19 plus years after stroke who came and took part in a study, and they have actually, not in a study, but were part of a therapy. They actually could improved 19 years after, and quite substantially, actually. So apparently, you can have somebody who is quite chronic. I mean, 19 years is
Quite chronic.
Quite chronic.
Yes.
But we believe that getting patients early in the game is more beneficial for the patients, and you can have larger gains and faster.
Norman Doidge has been a guest on this program many times, so we know all about brain plasticity and the brain that changes itself. What role does that play in FES?
That's it. This is essentially the method which allows to reprogram the brain by providing what the patient would like to do and providing proper movement of the arm and feedback to the system so you can retrain the system.
Let's take a look at another graphic, if we could. Lorraine is directing today. Lorraine, bring up this picture here. This is an early version, I gather, of your FES equipment. Give us an idea of how much technological plasticity was involved in the development of this equipment.
Right. So originally, this is generation number 2 of the device. We actually built a device which is a laboratory-grade system. So many of the protocols and the ways how we stimulate the patient, which is now part of the MindMove stimulator, had been tested on it. However, we have also went to the next generation of the hardware, because when you use conventional electrical stimulators like that one that you see in the video, on the image actually, they're not very pleasant. So when you stimulate the patient feels discomfort, and some people even feel pain. So we needed to go and design a system that is more comfortable for the patients, and now this is a part of the new device. So you're looking about 4 generations of hardware and software before we were ready actually to go and productize the system. So this is generation 5.
This is 5.0. Okay.
Exactly.
Can we bring that shot up one more time, Lorraine? Because I just want to look at it. Look at 1, 2, 3. It looks like 4 electrodes on each arm. Is that enough to really give it the jolt you need?
Depends what you're doing. So if one is doing just hand opening and closing, that's sufficient. But if one wants to get reaching and hand opening, then you need up to 8 channels. So this device actually has 8 channels, and we will fire 8 different muscle groups or muscles to generate desired movement. So the movements can be touching your chin, that's fairly simple, but reaching forward, opening hand, grabbing an object, retrieving it, that's fairly complex, and you will need 8 muscle groups to work in a synergy to do that.
Let's understand how you got to device 5.0.
Right.
How much do you think it cost from original idea to that prototype?
That's an expensive exercise for various reasons. First, technology development of the generation 1 and generation 2 probably were in the range of $1.5 million to do that.
Dollars, I assume.
Dollars.
Canadian
yes.
dollars.
Canadian dollars.
Okay.
Then we needed to do clinical trials. So we did, when you do small pilot trials with 5, 6, 7 patients, that's about $100,000, $150,000 a pop, sort of speaking. And then if you try to do randomized control trials, then you're looking at much larger price. So if you do proper randomized control trial, for example, with 60, 70 patients or 80 patients, you're looking almost at $1.5 to $2 million in costs today. So not only do you need to design technology, but you need to run randomized control trials because the technology is meaningless unless you can demonstrate it, that it works robustly on multiple patients and it's better than the conventional therapy or the therapy you are testing it against.
Let's bring this up. We've got another graphic here indicating the cost journey. There we go. We saw this before, all the way from technology creation, top left corner, moving across to the aha moment in 2001. Product launch, bottom right-hand corner. You're almost there. Tell us again, where did the money come from that allowed you to commercialize where you are today?
Right. So there are a couple of elements that happened which was very important for us. In the process, whenever we wanted to do a critical study, right, or critical development, it was usually the foundation. For example, Toronto Rehab Foundation would come forward and provide us with those funds that allow us to do high-risk type of projects. So for us, Toronto Rehab Foundation has played a pivotal role in bringing those funds that allow us to de-risk the system. Then what was very important when we went into launching the product, present CEO of the company, Diana Plura, and myself, we actually went to Ontario Centers of Excellence. So Ontario Centers of Excellence was very kind to us, sort of thing, and recognized the potential, and they helped us financially to actually engage proper people so we can actually put the business plan and what we wanted to do with the company. And the next phase was essentially angel investors. So we were very fortunate that in Ontario we had 20 individuals in 2012 who trusted the technology, trusted the team.
How much did they give?
They gave us about $2 million.
The angel investors.
The angel investors. That was absolutely fantastic. And I think at that time it was one of the largest angel investment that has happened.
You want to say who? Would we know the names of some of these people? Do you want to say who they are?
No, these are, I mean, I don't want to go through the names, but they're individuals who were in a position to help us, and they're not particularly famous individuals. Right?
Okay.
I mean, they're very well known in their field. They're excellent investors, and they're very competent individuals, and we're grateful to them. But it's not like a single individual.
Okay. Because we do hear in this country that there's no venture capital sector to speak of, right? It's extremely difficult to get people to you know, in essence, throw some money into the kitty and let's see where it goes, right?
Right.
Did you find that to be difficult in this case?
I think what was very important, we had really a privilege to meet exceptional people who immediately understood what we're trying to do. And I think besides trying to make a good investment from the financial point of view, I think almost all of them were altruistic. So this was also investment in the sense of we believe that this technology can help a lot of people. So we are ready to take a risk. So our investors were in that way extraordinary because they felt strongly that this is going to change lives of many people, and then they thought that it is worth taking the risk, not only just for financial purposes, but also for the purposes of helping people. And they've been with us ever since. I'm very grateful to them.
The Ontario healthcare system is a $50 billion a year enterprise. And obviously sometimes you have to spend money in order to save money. So with the investment in your program here, how much do you hope to ultimately save taxpayers of Ontario, government of Ontario, because the very expensive prospect of taking care of people who have strokes and injuries of this kind might be alleviated?
So let me give you an extreme example. Like if somebody has a spinal cord injury, we're moving to spinal cord injury because I have the numbers available readily. Okay. So if somebody has a spinal cord injury and it's a cervical level, which means they're not able to use their hands, you're looking at lifetime costs which are easily more than $1.8 million.
Per person?
Per person. If that person has the hand function back, which means they're high-level paraplegic individual, you can roughly shave about 0.8 million.
So we're down to $1 million now.
Right. So this 0.8 is exactly what you will get with this device. So if you deliver the therapy early in the game for spinal cord injury patients, you should be able to move them for quadriplegic patients to paraplegic patients and gave them the hand function back. That will probably reduce costs.
And what's the cost of the treatment?
The cost of the treatment right now, excluding, so there's a component of the therapist and there's a component of the device. 20 hours of the therapy is about $3,700. And we would recommend people to have 40 hours of therapy. They can have more than that, but 40 hours of therapy we have found to produce excellent outcomes. So
the $3,700 covers how much?
It covers 20 hours.
20 hours. So double that, you're talking $7,400. So you spend $7,400 and you could save $800,000.
That's correct.
Per person. So multiply that by
the number of individuals.
The number of individuals suffering from this.
Right.
So this thing pays for itself numerous times over.
In the first year.
In the first year, right.
In the first year.
So what are we waiting for?
So the reality is the following. There's a lot of people like us who come to OHIP and suggest that this is the most wonderful thing that ever exists. So they want to have the evidence. We have clinical evidence that suggests that this works very well. But they also want to have the evidence that financially this makes a difference. So we've been very fortunate to be engaged with Mars Excite program, which is essentially evaluating technologies like this. And it's running the randomized control trials in the multiple sites. And with Mars Excite and a PATH center from Hamilton, which is actually running the trial. And Dr. Mark Bailey, who is the principal investigator on the trial, we will test this in 90-plus stroke patients. And we will look at not only the clinical outcomes, but also the expenses and costs and savings to the system. And if that trial demonstrates the efficacy of the system also financially, not just clinically, I think that will be a lovely segue for OHIP to consider that seriously for funding.
Well, that was going to be the next question. I presume somebody from your team has had meetings with, if not the Minister of Health, then someone on his team, and said, look what we're doing here. We can save you a lot of money. Your government needs to save money.
Right.
How about it? Have you had those meetings yet?
We are trying. Our meetings have been through Excite program at Mars. And they're the funnel that we have used for this type of communications, to the best of my knowledge. I'm not running the company, so I can tell you what I know. So fundamentally, we are trying to do that. And so we welcome engagement from OHIP and ministry to talk to us and to look at this technology more carefully.
Because I presume at the end of the day, and you can tell me when that is, at the end of the day, you would like to see this treatment covered by the Ontario Health Insurance Plan.
Absolutely.
So that it is
absolutely
like any other treatment that somebody would go to get covered for.
The reason for that is because right now this is essentially private pay. And people have to go to designated physiotherapy clinics or occupational therapy clinics in order to have access to this technology. And not every individual is able to afford this type of treatment, although we feel strongly that it is more than worthwhile, but some people are not able to afford it. By having it covered through OHIP or through in U.S. Medicare and equivalent.
Anybody can get it then.
Then everybody can get it, and then we can help tremendous number of people. So, for example, every year in U.S. and Europe alone, we should be able to address at least 800,000 individuals, which is
amazing.
It's amazing. So we are looking forward to that moment in time when OHIP and Medicare, Medicaid will essentially pay for this. What is the good news, and we're very excited about, is that insurance companies see the value in that. So somebody who had a car accident and had a spinal cord injury or traumatic brain injury.
Private insurance company might
Private
cover
insurance companies are paying for it right now.
Oh, terrific. Okay. Milos Popovic, thanks so much for visiting us at TVO tonight. Fascinating work, and we wish you well with it.
Thank you very much. Thanks.
Help TVO create a better world through the power of learning. Visit supporttvo.org and make a tax-deductible donation today.